In this video, I'm going to be showing you how to go from Z to P, that is, how to start with a range of Z-scores and find the probability, or the proportion, or the percentage, or the area under the standard normal curve for that range of Z-scores. And in this video, we're going to be doing it using technology, as compared to the other video where I showed you how to do it using that table. Now, there are three kinds of things that you could be asked to find. The area to the left of any particular Z value, or the probability that Z is less than some particular number. The area to the right of any particular Z value, or the probability that Z is greater than some particular number. Or the area between two different Z values, which corresponds to the probability of Z being between those two numbers. And I'm going to start with that last kind of problem, because it's maybe easiest to understand when you do things the graphing calculator way. So you can use a graphing calculator like a TI-83 or TI-84. You can use the Desmos calculator app that I've shown you before and said you could get to use on your phone or use it online in a web browser. You can use Excel to find normal distribution probabilities. There are various different websites that you can go to and type in the numbers and it'll give you what you need. So I'll show you how some of these work. So we're going to do this example. What is the area under the standard normal curve between where Z is negative 0.88 and where Z is positive 1.10? That is the probability of Z being between those two numbers. Now, suppose you have a TI graphing calculator. You would press the second button and then the button that says DISTR above it. And you'll get a menu that looks like this. And what we want is number 2 on that list, the one that says normal CDF. Not normal PDF, but normal CDF. So select that, and then depending on what exact model of calculator you have and how it's set up or what mode it's in, one of two things will appear. You will either see something like this, just the word normal CDF with a parenthesis. So if that's what you see, we're just going to put in these two numbers separated by a comma. So I'm going to put in negative 0.88, comma, 1.10, close the parentheses, hit enter, and we get our answer. It's about 0.6749. Now, on some calculators, when you go to the distributions menu and select normal CDF, this is what will come up. You'll get a little screen here. It'll say normal CDF at the top, and then it will have places for lower and upper, and we're going to change those to these two numbers. So lower, I'm going to type in negative 0.88, and for upper, I'm going to type in 1.10. And then we should have a 0 and a 1 here. If these don't say 0 and 1, you should change them so that they do. The 0 is because the mean of the standard normal distribution, the Z-scores, is 0, and the standard deviation of the Z-scores is 1. So if we're just working with Z-scores, mu should be 0 and sigma should be 1. And then just go down and highlight paste, hit enter, and then hit enter again. And it will give you the answer, 0.6749. Now here's how you can do this using the Desmos graphing calculator, either in a web browser or the app like on your phone. So under functions, we're going to go to the distributions, and we are going to select normal dist for the normal distribution. Notice here, it showed us a little bell-shaped normal curve here, and it says mean equals 0 and standard deviation equals 1, which is what we want. Now I'm going to check the box next to find cumulative probability. And then what shows up here are a couple of blanks, one for min and one for max. And I'm going to type in my two numbers there. So for min, I'm going to put in the number negative 0.88. And for max, I'm going to put in the number positive 1.10. And then the number that shows up in the little box here is 0.6749. That is the answer that we were looking for. And it actually shaded in that part of the graph between where z is negative 0.88 and where it's positive 1.10. There are also web-based websites and web apps that will do this for you. Here's one of them that I think is fairly easy to use. I'll give you a link to this on Canvas. So when you go here, make sure that the dot next to normal distribution is filled in. For what we're doing right now, we are working with the normal distribution. And there should be a 0 in the box for mean and a 1 in the box for standard deviation. And then we want to calculate, well, what we're doing right now is where we're between two different numbers. So that's the third one here. So I'll select that and I will type in the numbers in those two boxes. In the first box, we have the number negative 0.88. In the second box, we have the number 1.10. And then when I click on calculate, it gives me the answer. It says the probability of, it calls it x, being between negative 0.88 and 1.1 is 0.6749. And it shows me a graph here with the normal curve and the region that we're talking about between where z is negative 0.88 and where z is positive 1.1, shows it that is shaded in. So try doing this next example one of the ways that I just showed you, with a graphing calculator or with Desmos or with that website. Find the probability of z being between 0.39 and 2.75, or the area under the standard normal curve between those two z values. You should get something that's pretty close to 0.3453. Try this one. The probability of z being between negative 2.9 and negative 1.9. You should get an answer close to 0.268. Now, what about something like this? The total area under the standard normal curve to the right of z equals negative 1.90. So here we're not talking about being between negative 1.90 and some other number. We're talking about being between negative 1.90 and infinity. The z's start at negative 1.90 and then they just keep on going. So the way you would put this into a graphing calculator is when you select your normal CDF, for your lower number, you give it negative 1.90. And for your upper number, well, we can't really put in infinity, but we can put in just a really big number, so big that it's practically infinity. So something like 9999 will work. And the answer comes out to be 0.97128 something. If we round that to 4 decimal places, it's 0.9713. If we do this on Desmos, select functions, normal dist, find cumulative probability, put in negative 1.90 for the min, and just leave the max as it actually shows a little infinity sign there. So if we just leave it as that, it will give us the answer of 0.97128 and so on, about 0.9713. If we use this website, we would select the second of the three, the probability of x being greater than, and we'd put in our number, negative 1.90, hit calculate, and here it shows it, and there's the answer, 0.9713. So if you think you understand how that works, try using one of those methods to answer this question, to find the total area under the standard normal curve to the right of where z is positive 1.42. That is the probability of z being greater than 1.42. You should get an answer of 0.0778. Now, for this kind of question, what's the total area under the standard normal curve to the left of z equals 0.67, or the probability of z being less than 0.67. To put this into a graphing calculator, I go to the distributions menu, select normal CDF. This time my lower limit is negative infinity. This is like everything from negative infinity up to 0.67. And I can't really put in negative infinity, but I can put in something like negative 9999, which is as far off as that's close enough to negative infinity. And then for my upper limit, where I stop at, that's 0.67. Make sure we got 0 for the mean and 1 for the standard deviation, and paste that and hit enter. And it shows up as 0.7486 if you abbreviate it, if you round it to 4 decimal places. Here's how we would do that on Desmos. Select Functions, Normal Dist, find Cumulative Probability. This time we leave the minimum blank. You notice there's a little faint negative infinity symbol there, so we'll just leave that there. And then for the maximum, we'll put our upper limit, which was 0.67. And it shows up as 0.74857, about 0.7486. And with this website, make sure we've selected normal distribution, mean 0, standard deviation 1. And this is the first choice, the one of the probability of x being less than some number. And the number I'll fill in is 0.67. Then I'll hit calculate. It shows me the graph and it gives me the answer here in red, 0.748571, about 0.7486. So if you think you see how that works, try doing this using one of those methods. The total area under the standard normal curve to the left of where z equals negative 2.08, or the probability of z being less than negative 0.08, and you should get an answer of 0.0188. Now, I also mentioned that you could do this using Excel, and here's how that works. In Excel, go to some blank cell in your spreadsheet, type in equals NORM dot S dot DIST, so that's for the standard normal distribution, and then parenthesis, and you're going to put in just one z value. In the example one of the examples we were doing, the z value was, negative 2.08. And then put a comma and type the word true. And what it gives you, 0.01876 or about 0.0188, is the probability of z being less than that number. So that's the same sort of thing as what you would look up on table E if you were doing it using the table. Now, for other kinds of probabilities, like z being greater than a number or between two different numbers, you'd have to either subtract this from one or look up two separate things and subtract them from each other, like I explained in the video about using table E.